Okay, let's talk about our precision measurement unit. We're talking about accuracy and tolerance today. I gave you an extra long timeline to do your assignment just because I was at school doing end of year stuff. So hopefully you've done okay on the assignment one. We're going to talk about uncertainty today. So uncertainty is, it's related to precision. On the first lesson, we were talking about precision, which is the smallest increment that you can see on a measuring tool. But when you use a measuring tool, as you know, if you've used a ruler or even tried to tell time on a smaller watch, it is difficult to measure something exactly. For example, you cannot measure the exact length of a pencil with a ruler. You might get close depending on the precision of your ruler, but are you exactly correct? Every measurement has uncertainty built into it. Uncertainty is defined as half the precision. So if you did okay on the first lesson, you'll do fine on this lesson because all it is taking your precision, whatever you calculated for precision, and dividing it in half. This means that you cannot determine uncertainty before you determine precision. In other words, uncertainty is equal to precision divided by 2. So let's take a look at example 1. Determine the precision and uncertainty of each of the following. An airplane gauge. So I look at this gauge, and once again, I can see, let's see, if I look from 8 to 10, for example, that measurement is 2 units, right? 2 units of measurement, which in this case is, I'm not sure what it's measured in. I think it's air to fuel ratio. So we'll just say 2 units from 8 to 10. That is a distance of 2. Now I'm going to count the ticks. I'm going to start at 8. I don't include the one I start with. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2. The precision equals 2 divided by 10, 2 units, divided by 10 ticks. Okay, which would be, let's see, what's 2 divided by 10? 0.2. And again, I'm not sure of the, I guess 0.2 air to fuel. Okay, so let's see if that works out. 0.2. So 8.2, 8.4, 8.6, 8.8, 9. Yep, that works out. So the precision is 0.2. So the uncertainty, which I'm going to shorten to UC. Sorry about that. I'm always trying to get my paper straight and it never works. Uncertainty equals precision divided by 2. So 0.2 divided by 2. The uncertainty will be 0.1. Okay? So find your precision like you did in assignment 1, divide it in half, cut it in half, divide by 2. So let's look at the stopwatch. Let's see, the measurement is what? Well, let's just even take from 0 to 5. The measurement is 5 seconds. Okay, and let's see what the precision will be. Precision equals 5 seconds divided by how many ticks? I don't include the one I start with. 1, well, actually there's one, even though it's hard to see, I think there's one little one in between. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 ticks. So I don't know if on your booklet, but there's between these larger ticks, there's a smaller one. So 2, 4, 6, 8, 10. 5 divided by 10 is 0.5 seconds. So the uncertainty is 0.5 divided by 2. Hi, Cynthia, is 0.25. So that's the uncertainty. Now, it might not mean a lot to us now, but if you were in an industry and you were measuring really precise things, or even just measuring a lot of nuts and bolts, for example, or something in construction, they would be very concerned with uncertainty. Because that uncertainty means that they might have to order a little more in construction materials. So they want to allow for uncertainty, but they don't want to order too much more, because that's a waste of money too, right? A waste of money materials. All right, let's take this next one. Let's see, I'm going to take this measurement. I think we've seen this ruler before. So that's 10 centimeters. Precision equals 10 divided by 2. So the precision is 5 centimeters, and the uncertainty is 5 divided by 2. So that will be 2.5. Okay, so it's 5 centimeters, uncertainty of 2.5. All right, so some of these pictures are the same as we did before, right? And now we're moving on to the examples without any pictures. So we know how to do that, right? I look for my smallest unit, and this is the ones. So that would represent, this placeholder would represent 1 kilometer. So that's the precision. So the uncertainty is 1 divided by 2, or you could call it a decimal, 0.5 kilometer. That's the uncertainty. This one, okay, what's my smallest unit of measure is here. So that's in the hundredths column. So my precision will be, when we do it this way, precision is always just a collection of zeros and ones, right? So my precision would be 0.01. Precision is 0.01 seconds, a hundredth of a second. So the uncertainty is 0.01 divided by 2. So that's going to be a teeny tiny number, right? 0.005, and I should probably include my lead zero. So this is the uncertainty precision. Okay. Last one, we're back to just 1 decimal, so the precision is just 0.1. Okay. So the 1 goes where the last decimal digit is. So wherever your last decimal digit is, that's where the 1 goes. And you just fill in the others with zeros if you have to. So uncertainty is 0.1 divided by 2. So that's 0.05 centimeters. Precision, uncertainty. Okay, example 3. The weather person says that the temperature outside is 35.8 degrees Celsius. Determine the uncertainty of this measurement and then write it in the form, whatever your measurement is, which is the 35.8, right? That's my measurement. 35.8 plus or minus. Okay, I just have to figure out the uncertainty. Always have to start with precision. So precision is, it's just like the last example we did. There's 1 decimal digit, so the 1 will go in the decimal digit place. Precision is 0.1. Uncertainty is then therefore, cut this in half, 0.05. Okay, so that's what they want here. Now, if I include my degrees Celsius here, I don't necessarily have to include it on the end either, because it's understood that it's degrees Celsius. So what this tells, though, this relays to the reader, or to whoever you're communicating this information, the temperature outside is 35.8 degrees Celsius, plus or minus 0.05. That's telling the reader you're a little uncertain of the exact measure. So it's kind of like a give or take 0.05. That means if I add that 0.05 onto this 35.8, actually the temperature is going to be in a range, right? I know the temperature should be somewhat within the stated range. So I'm going to say, well, the temperature outside is probably 35.75 to 35.85. That's what uncertainty means. It's just relaying a little bit of uncertainty. All right, let's take example 4. You are told that the height of a tree is 3.7 meters. Write this measurement in the form. Okay, so this is my measurement. Let's find out the uncertainty. The precision would be, okay, 2 decimal places, so my 1 goes at the last decimal place. Okay, so then I'm just going to write it. And I guess I'm going to put my meters here. So that's it. So calculating uncertainty, just letting the reader know that there's a reason there's uncertainties. If we look at this application question next, like I'm on page 11, since every measurement has uncertainty, if you add together 2 measurements, you must also add together their uncertainties. So let's take a look at that. A string that is 10.3 centimeters long is placed beside another string that is 5 centimeters long. Find the total length of both strings, including uncertainty. Okay, so let's take a look at this measurement. So the measurement is 10.3. That's centimeters, right? What would the uncertainty be? Well, precision would be, this measurement is precise to 0.01. So the uncertainty is going to be divided by 2. Oops, I added too many zeros. 0.05. Okay, so this will be, this measure is going to be stated as 10.3 plus or minus 0.05 centimeters. Okay, so that's my first measurement. Let's take a look at the second measurement. The measurement is 5 plus or minus, the precision will be just 1 centimeter. So the uncertainty is 1 divided by 2, 0.05. Okay, so here's my 2 measurements. Find the total length of both strings, including uncertainty. So what we're going to do is we're going to add the string lengths, okay? The total length right, is going to be 10 plus 3, 10.3 plus 5, 10.3 plus 5 equals 15.3, right? So 15.3. Let's do this total uncertainty. What will the total uncertainty be? 0.05 plus 0.5 0.55. Okay, so that is my final answer. So just add the measurements, but you have to find the uncertainties separately and then add the uncertainties. Let's take a look at this last one. You are building a wooden pathway for your garden and you cut 3 pieces of board. One piece is 2.09 meters, the second piece 2.9, and the third 1.99. Determine the total length of all 3 boards. All right. So the first board is 2.09. Let's do it this way. Precision is 0.01. So uncertainty is 0.005. I'm just cutting that in half. The second board is 2.1. Precision is 0.1. Uncertainty is 0.05. The third board is 1.99. Again, the precision is the same as the first because it's the same number of decimal digits. So the uncertainty is, should add my leading zeros. Okay, so the total length is, I add all these 3 up. And I get 6.18. And the total uncertainty is okay, so my total measurement is 6.18 plus or minus 6. And the reason you want to do is every time you take a measure, there's uncertainty involved, right? So you want to make sure that if you were going to the store to buy a piece of lumber, you want to make sure you add that uncertainty in, right? Most people address that by buying just a little extra. So I am going to assign assignment 2 to you, but before that, I actually am going to talk about accuracy. Or actually, what I'm going to get you to do is I'm going to get you to read. I'm going to assign assignment 3 in lesson 3. My paper's all marked up. I'm going to get you to read about accuracy as well. And I'll briefly talk about that tomorrow. And then tomorrow, I'm going to talk to you about tolerance. And I might just get through. So there's no assignment for accuracy. I'm just going to give a real quick little, I guess, talk about accuracy. And then I'll finish everything up with tolerance. So just a reminder, Friday's the last day to hand anything in. I have to have the marks in by Friday or like by Monday. So I'm going to be marking everything by Friday. And that's it. Like I say, if you want to keep working ahead a little bit, please keep working ahead. And we're just going to finish this unit out. And if you work ahead, then I can answer questions during class too. I might even actually record a couple of lessons ahead of time and then try and post those so I can have a bit of a lesson after you've already seen the video. Okay, that's it for now. So try and keep working through the unit, and I will talk to you tomorrow.